Hello and welcome once again to LFI Educates. We are in chapter 2, units and measurement. Now today we are going to discuss about measurement of length. There are two methods to measure length. One is called direct method and the second one is called indirect method. In direct method, we use our instruments like scale, vernier calipers, and then we use screw gauge. Small instruments we use to measure small distances or small lengths, like our ordinary scale, as you already know, that you use it in drawing diagrams. These two, vernier and screw gauge, we'll be discussing in practical classes more in detail. We can measure the length directly with these three instruments. That is for short distances. But this indirect method is used to measure large distances, like a distance between a planet and Earth, or distance between the moon and Earth, that we can do with the help of indirect method. In indirect method, one thing you have to know, or most generally it is used, that is your parallax method. Now first of all, let us see what is parallax. Parallax is the apparent shift of position of an object when viewed from two different locations. Like suppose this is the pen. If I close my left eye and view, and after some time if I open the left eye and then close my right eye suddenly, then I can see that the object gets shifted. This apparent shift in the object when viewed from two different positions, we call it as parallax. This method is helpful for measuring large distances, like a distance between a planet and the Earth, or between Earth and Moon, suppose Earth and Moon. Let us do and see to measure the distance between Earth and Moon. Let us take. Now suppose this is the position of the moon. Let us mark it as S. This is the surface of the Earth. Now let us choose two different positions of the surface of the Earth as A and B. And if you look at this moon from A, this is your line of sight, and if you draw a vertical line here like this, at this point also if you draw a vertical line, then you will get this angle. You can find out with an instrument called sextant. Let us mark this as θ1. Now as alternate interior angles are equal, this angle also will be θ1. The same way, from position B, again you will see the moon, and here if you draw one vertical line on top of your head, you can measure this angle θ2. Now this θ2 will be equal to this angle θ2. So the sum of this θ1 and θ2 together, if you write it as theta, this angle ASB will be called as the parallax angle, or we call it as parallactic angle. So here theta is equal to θ1 plus θ2. So you can find out this angle. Even if you cannot go and reach the moon from the Earth itself, you can measure. After knowing this angle and the distance from A to B, let us take it as small b, you can measure this distance d between Earth and the Sun. This one also will be almost the same, approximately the same. What you do is, You use this formula, angle equal to arc length, plane angle equal to arc length divided by the radius, as we have discussed earlier while discussing about plane angle. And here the angle, your parallax angle is theta. And the arc length, which part to take it as arc length? This AB you will have to take it as arc length. You will imagine like this. This is taken from a big circle. You can imagine this way. You can imagine this way. So this is a part of an arc AB. That length we are taking it as B. So arc length, if I take it as B, then this will become the radius. This will become the center where the moon is placed. So this distance we are taking it as capital letter D. So from here, D is equal to B divided by theta. Knowing the value of B, this distance from A to B, as you are moving from one position to another position, you can measure it. And then theta, with the help of sextant, you found out theta 1 and theta 2. And these two angles, if you add it, you get the parallel angle theta. You can know the distance between the earth and the moon. This is the way you measure the distance, large distances, with the help of parallax method. With this method, you can even estimate the size of a planet or size of moon or any heavenly body. Let us see. We use the same method to measure the size of moon approximately or any other planet. Suppose this is the size of your moon. Let us take an example. This is your moon. Then you are standing here on the surface of the earth. This is the point of observation O. This is your earth. Then what you have to do is, once you look at one end of the moon and once you look at the other end of the moon from the same position, if you look at two different places, with the help of sextant, you can measure this parallel angle that we will call as theta. And then these two ends of the moon, if I write it as AB, this will give you the diameter of the moon. Let me mark it as D. And this distance, with this formula already, suppose we have measured it, the distance between the moon and the earth, that we are writing it as capital D. Then what you have to do is, the same formula you use it, but this time, this one will become the radius, this will become the center of the circle, and we have to take it this way. AB will become the arc length. AB will become the arc length. Diameter, radius will remain the same, capital D, and the parallel angle will be angle AOB. So if you use the same formula, angle equal to arc length divided by radius, then angle is theta, the parallel angle. Arc length here it is D, and the radius it is capital D we are using. So from here you can measure the diameter of the planet using this formula, theta into D. This way you can find out the size of the moon. Knowing the diameter means we know the size of the moon. Now let us estimate the size of a very small distances. Here, estimation of very small distances, that means we are going to find out the size of a molecule of oleic acid, the molecular size, the diameter. Now this includes a several step process. Let me write down stepwise. In step 1, we'll dissolve 1 centimeter cube of oleic acid in 20 centimeter cube of alcohol. After we dissolve 1 centimeter cube of oleic acid in 20 centimeter cube of alcohol, then in the second step, we take 1 centimeter cube of this solution, 1 centimeter cube of this solution, is dissolved again in 20 centimeter cube of alcohol, so that the concentration of the solution is 1 by 20 into 20 centimeter cube of oleic acid per centimeter cube of alcohol. Now in the third step, we take a trough filled with water and sprinkle some lycopodium powder, we call it as lycopodium powder, after sprinkling some lycopodium powder, we take n drops of this solution which we have prepared the concentration of oleic acid. We take n drops of the solution and we take n drops of the solution and drop over the surface of water. To form a thin film. Then in step 4, we write down the volume of oleic acid that we have dropped on the surface of water. Volume of n drops of oleic acid will be n times the volume V, how much you have dropped. Then the amount of oleic acid in the solution, the volume will be in centimeter cube. Therefore, the amount of oleic acid in the solution will be NV times the concentration, that is 20 into 20 centimeter cube. This will be the amount of oleic acid in the solution. Now, the thickness of oleic acid, that you will have to measure it. The thickness of oleic acid, let us write it as T, will be equal to the amount or the volume of oleic acid in the solution divided by the area of film. On the film, how much area it has occupied, the oleic acid. If you divide it, then you will get, from volume, if you divide this area of film, you will get the thickness of oleic acid. So T will be amount or the volume of folic acid you found out here, NB divided by 20 into 20 multiplied by area. So dividing this volume by area, then you will get in terms of centimeter. This measurement will give you the approximate, the thickness of the oleic acid, that will give you the approximate size or the molecular size of oleic acid. This thickness will give us the approximate molecular size of oleic acid. This is how you can estimate the size, the molecular size. This is the range of length. We can measure from 10 to the power minus 15 meter to 10 to the power 26 meter. This is for the diameter of proton or size of proton. To the distance of observable universe or the boundaries of our observable universe. So this is the range of length that we can measure in physics. Thank you and have a nice day. Stay tuned with LFI Educates.